On this page, we'll look at some more antiderivative rules. The first one is the antiderivative of a constant times a function. So in differentiation, we're actually allowed to pull constants out front of the derivative and just do the derivative of what's left and multiply the constant back in later. So if I was going to write that derivative rule that we all may be familiar with, the derivative of a constant times a function equals the constant times the derivative of that function. And so this is actually similar, but this is the reverse. It's anti-differentiation. So let's see how it works. We want to do the antiderivative here of 3x squared dx. And we can take that 3 now and pull it out front of the integral sign. And then just find the antiderivative of what's left. And we'll multiply the 3 back in later. So the antiderivative of x squared, according to the power rule that we had looked at recently, would be x to the third over 3. And we have to put plus c in there. Now we can actually just cancel these 3's here. And that is going to leave us with x to the third plus c as our final answer. So just like constant multipliers can be moved to the front outside of differentiation, constant multipliers can be moved to the front outside of integrations as well. Try it for yourself on the next one, and then I'll give my answer. Okay, so we want to do an antiderivative of 2x to the 3/4. Pull that 2 out front, and now we just want the antiderivative of x to the 3/4. According to the power rule, I should add 1 to the 3/4. So I would get 2x to the 7/4. And then I would divide by 7/4. But I'd rather multiply by the reciprocal. That would be 4/7. So let's multiply this final result by 4/7. That'll give us 8/7 x to the 7/4. And that's the final answer. All right, you may recall from differentiation that the derivative of e to the x is itself. It's one of the only functions where its derivative is himself. I guess 0 would be another one. The derivative of 0 is 0. But it shouldn't be surprising that the antiderivative of e to the x is itself too. But because we're doing anti-differentiation, we have to throw that plus c on there as well. So I'm going to try to use this rule to get an antiderivative of 2e to the x. But this also requires that I know the constant multiplier rule too. I have to bring the 2 out front. Okay, now the antiderivative of e to the x is itself plus c. So let's put our 2. We always have to bring our constant, onto the next step. And then write our antiderivative, which is himself. And then put plus c, and it's done. Try the next one. And then I'll give my answer. Okay, here we should have integral of 1/4 e to the x dx. That's the notation we want to use. Pull our 1/4 out. And now we just want to get a formula for this integral of e to the x dx. And it's just himself plus c. And that's the answer. All right, you may recall from differentiation that the derivative of ln x was 1 over x. So, not surprisingly, the antiderivative of 1 over x is ln x. But actually here there are a couple of new modifications that have to be introduced. One of these is the absolute value is placed around the variable x. Now, in order to see why that's the case, you may wish to look at a function here of 1 over x as a graph. So I'm just using desmos.com/calculator just to make an easy plot of 1 over x. We can see that 1 over x has values on the left side of the y-axis and the right side of the y-axis. It has values in the negative x and values in the positive x. What happens when we draw the function ln x? You may recall you can't take a natural log of a negative number. And so it doesn't have values on the left side of the origin here. So we want to put an absolute value around the x to make sure that we do get an antiderivative for those left side values. So what I'll do here is I'll plot y equals ln of negative x to show the values of the antiderivative that you would get for that left side. Okay, so here the derivative of ln x is this purple curve here. And we can also see that the derivative of the negative side of the ln negative x would be the purple values as well. And so now it's more complete. All right, so let's try an antiderivative of 2 over x dx. I can pull the 2 out front as a constant, leaving behind 1 over x dx, which is exactly what we need according to the general rule here. We will make it now 2 ln absolute value x plus c. And that'll be our final answer. Try the last one. Okay, we want the antiderivative of 12x to the negative 1. Pull the 12 out front. And now here, it may be tempting to use the power rule on that. But that's the one power of x that you can't do power rule on. That's why we need this rule. So x to the negative 1 is 1 over x. So this is going to give us 12 ln x plus c.